Good day. My name is Veytri Yogan with Naqib in a team, and today we'll be presenting the Smart Emergency Evacuation System. This system is an IoT based solution for automating emergency responses in residential and building settings. Its core features include real time monitoring of environmental conditions like smoke, temperature, and gas levels, proactive automation to ventilate, unlock exits, and guide evacuation with sequential LEDs, remote connectivity for cloud-based monitoring and email alerts, manual override for occupant control during emergencies. Why do we need this system in the first place? Traditional alarm systems are reactive and lack proactive measures. They fail to provide clear evacuation guidance or automation, leaving occupants vulnerable during crisis. The system proactively ensures safety by automating responses, reducing delays, and enhancing evacuation guidance. Let's have a look at the high-level system architecture. Sensors like MQ2 and DHT11 collect environmental data. The ESP32 processes data, triggers actuators, and sends information to the cloud. Actuators like servo motors, relays, and LEDs perform automated safety actions. The cloud platform enables real-time monitoring and alerts, also email alerts via SMTP. Next, let's have a look at the integration in terms of the block diagram for ease of visualization. The MQ2 and DHT11 sensors for detecting gas, smoke, humidity, and environmental conditions. Servo motors for unlocking emergency exits, relays and shaft motors for ventilation, sequential LEDs for guided evacuation paths, all controlled by the Maker Feather ESP32. Now let's have a deep dive on the circuit design itself. Sensors and actuators connect to the ESP32 via digital and analog pins. Relays manage high power devices like fans, while specifically the motor shaft. LEDs are controlled through resistors for sequential lighting. Push button is also integrated, which provides manual override in case of emergency or faulty alarms. As you can see here, this is the specific circuit design and technical implementation of this particular system. Now, how do we integrate that to the cloud? We are exclusively using the V1 IoT cloud platform, which enables seamless data management. We are looking at real time monitoring, which visualizes sensor data on a user friendly dashboard, data transmission, which uses MQTT for efficient communication, and we are also looking at alerts, which are sending email notifications via SMTP when thresholds are exceeded. And in this case, the threshold is 800 for the gas sensor. And we are looking at automated workflows and actuators responses based on triggers. Next, let's have a look at the implementation or the real world implementation itself. In homes, sensors and actuators are strategically placed in key areas like kitchens and hallways. In buildings, the system integrates across multiple floors, enabling centralized safety management. This design ensures rapid response and easy adaptability for various environments. Upon that, this is the actual circuit implementation that we have done. And as you can see, there's the hallway, and this is the imitation in a kitchen of how we could implement this system for emergency evacuation purposes. Next, looking at the sustainable development goals, and this project aligns with two different ones, which includes SDG 11, sustainable cities and communities, enhances safety and resilience by minimizing disaster impact, and SDG 9, industry innovation and infrastructure, which promotes modern IoT driven infrastructure to support sustainable development. Welcome to the live demo of our smart emergency evacuation system. The demo is being located at kitchen area. The MQ2 sensor is placed in the kitchen near gas appliances to detect smoke and gas leakage. The DHT11 sensor is located in the hallway to monitor temperature and humidity across the house. A servo motor is installed on the main exit door for automatic opening during emergencies, while the relay and exhaust fan are positioned in the kitchen for clearing smoke and hazardous gases. LEDs are mounted along the hallways at eye level to guide evacuation, and all data is processed by the ESP32 microcontroller and transmitted to the V1 IoT cloud for real-time monitoring and alerts. Let's see it in action. Now, as you can see, the panels representing all real-time data collection, and the threshold at 800 ppm for the MQ2 sensors is being set as we light up. The lightest of butane gas is detecting, and as you can see, it has reached the threshold of 800 ppm with the actuators activated, which includes the door opening and the fan opening, exhaust fan. And at this point, we are looking at the LED light sequentially being displayed and also the email being sent to us. As we can see over on the right corner of the panel, the dashboard real-time monitoring is also monitoring the current gas levels, and the doors are still left open, the exhaust system is still left open. As we press on the push button for emergency controls, we are shutting down the entire system, which includes the door closage, the actuator or the exhaust fan being off, and also the LEDs being off and does not light up. That's all from us. Thank you very much.